Hey everybody, Bill Grismore here with 27 Virtual, and I'd like to welcome you to this video presentation on NSX. In this particular video, we're going to focus on what are the requirements, what are the prerequisites that I need to have in place before I ever think about even installing NSX or deploying NSX in my environment. Let's take a look. So here's a basic vSphere environment, and I want to put NSX on top of this. And the number one requirement before we ever install NSX, make it a little bit smaller, the number one requirement is my ESXi hosts have to be 5.5 latest update or higher. My vCenter should be the latest 5.5 update or higher. And the reason we want to go with the latest version of vCenter, whenever possible, at least 5.5 or higher, is that we get a brand new, nice and shiny, dedicated TCP/IP stack for VXLAN. So what I mean is, without 5.5, if I had just 5.1 or older, I would get a VM kernel NIC for management, I would get an IP address, I would get a mask, and I would get a gateway. I get a VM kernel NIC for vMotion. I would only get an IP address and a mask, no gateway. VM kernel NIC for IP storage, IP address, mask, no gateway. Now these IP addresses could all be the same or they could all be different. You could give different IP addresses, but I have a single TCP/IP stack that I'm working with. And that limits me to the number of gateways I can have. So once you go to 5.5, when I deploy my VM kernel NIC for VXLAN, for my VTEP, what's going to happen is I'm going to get a dedicated TCP/IP stack. And what that means, why that's so important, is I get an IP address, a mask, and I get my very own gateway. I've never been so excited to get a gateway in my life. Like, I have a gateway for my VXLAN. It's like Christmas. So basically what it means is that I can take a layer 2 frame, and I have my VTEP sitting down here. So I can take my layer 2 frame, and let's put a VM on host number 1, and let's put a VM like way over here. And we have the VTEPs on every single host. We'll just put a V real quick, right? VTEP. We've done all the NSX VXLAN prep. Let's just pretend for a minute. I'm getting way ahead of myself. I just want to show you this real quick. So basically what this means is that if I don't have 5.5 and I try to deploy NSX, my VTEP would not have a gateway. So my traffic would not have a way to get to this IP address here to forward the traffic across the layer 3 to be able to reach my destination. So I could take the layer 2 packet, send the layer 2 packet out of the VM, get it down to the VTEP, right? The VTEP would take it and add a VXLAN header to it. And then I would take this packet with this VXLAN header, but how would I get it across the layer 3, right? So if I'm in 5.1 or 5.0 older versions, I wouldn't have the ability to put a gateway on my VM kernel NIC for VXLAN. So how would I know to forward the frame across the layer 3 to get it to the destination, right? There'd be no way to do it without maybe doing a static route or something like that. So as long as you're 5.5 or higher, the VTEP will have a gateway, which means it will have that next hop information to be able to take the layer 2 frame, encapsulate it in a VXLAN header, route it across the layer 3, deliver it to this host, and then we would decapsulate this frame, remove the VXLAN header, right? Strip the header off and be able to move the layer 2 frame or packet at this point up into the VM. All of that would not be possible without that gateway. Very, very important. And I don't get the gateway unless I have that additional TCP/IP stack. And that's what going to 5.5 does. It gives us the ability to have this TCP/IP stack here for our normal VM kernel NICs and an additional TCP/IP stack to give us the gateway for the VTEP. Very, very important, is absolutely the number one concern. The number two concern, the number two most important item, the number two most important prerequisite before we ever consider installing NSX is we got to have a virtual distributed switch, or some people may call it a distributed virtual switch. You say tomato, I say tomato, whatever, doesn't really matter. If you want to do anything with NSX, we've got to have virtual distributed switches, right? We cannot use standard switches. But the good news is, the most important thing here is if you purchase an NSX license, you're going to get the ability to create virtual distributed switches by simply putting in your NSX license key. That means if you have standard edition and you have not yet upgraded to enterprise edition, by purchasing that NSX license, you can actually start creating virtual distributed switches. Now, that's not going to give you all the features of Enterprise Plus, but you're going to be able to create virtual distributed switches, and that's a requirement for NSX. So just purchase NSX. I'm sure it's on sale somewhere near you. Purchase NSX, get the license key, and you can start creating virtual distributed switches, and you do not have to upgrade to Enterprise Plus. You do not have to upgrade to Enterprise Plus. Not a requirement. Don't need it. And then you start building your VDSs. Got to have VDSs in order to do NSX. We'll just say VDS here, and a VDS here. Got to have them. Can't use standard switches. With the VDSs, the other thing I wanted to say is that whenever you deploy NSX, you may decide just to do microsegmentation. When you go to do microsegmentation, you cannot use standard switches. You have to upgrade to distributed virtual switches. The thing that's also important is if you want to do microsegmentation, you don't have to have VXLAN backed port groups. You can have just VLAN backed port groups, regular port groups that are VLAN backed. So if you want to do microsegmentation, you have to have distributed virtual switches, but you do not have to have VXLAN. VXLAN is not a requirement for microsegmentation. Is not a requirement. The only thing that we're requiring is that you have a virtual distributed switch. So we don't have to have VXLAN for microsegmentation. VLANs will work fine, and VDSs will work fine, or DVSs. That's it. That's the only requirement. So there you go. And that was number 2. Moving right along, number 3, most important feature that we have to have configured or thought about before we deploy NSX is your physical network card. Make sure it's on the hardware compatibility list. You want to try to go for 10 gig. 1 gig will work. 10 gig is kind of your sweet spot. There's newer technology to get you up to, I think there's like 25 gig now, and there's even 40 gig. Of course, you have to buy corresponding switches that support this, right? So, as you move up the list, it's going to get more expensive. The one thing that we want to emphasize, though, is that 10 gig is kind of our sweet spot, if you will. All right, so 10 gig is kind of nice. We like 10 gig. Make sure, again, that it's on the hardware compatibility list. Go with 10 gig. Make sure your switches are 10 gig, of course. But the thing that we're really looking for on these 10 gigs is the ability to support something called VXLAN offload, right? So VXLAN offload is a real important thing. And basically what that means is that on your network cards, on your host, there's going to be a chip here with some software baked into it that when the frame leaves the host, when I take that layer 2 packet, here's my VM. When my layer 2 packet leaves this VM right here, let me grab it. When this packet leaves the VM, goes to leave the host, the VTEP's going to have to take this layer 2 packet, frame it up, encapsulate it, put it on the network. Put the bits on the wire. The question is, when it gets here, who's going to be doing the VXLAN encapsulation on the way out? As it leaves, who's going to encap it on the way out? And who's going to decap it on the way in? And when I say who, I mean, is it going to be the CPU on the host that's doing the encapping and decapping, or is it going to be the CPU or the ASIC on the network adapter? If the network card supports VXLAN offloading, we're going to take the load off of the CPU, and we're going to let your physical network card do the heavy lifting. So that's very important. Another feature that we can leverage that's important is something called receive side scaling. So receive side scaling, if I can try to map this out a little bit, imagine we have 1, 2, let me do 1, 2, 3, 4 cores. We'll say we have 4 cores here. Of course, our host probably has way more than 4 cores, right? It's probably got like 32 core or something. But just as an example, let's bring these guys down in here. So these are the cores on the host, and I'm receiving packets coming in off the wire. And what's going to happen is we're going to build queues off of our network adapter that can drop packets into these different queues. So I'm not really sure of a good way to draw this. So we have, here's my adapter. Actually, let's do it like this. Let's say that we'll just do them in a row. 1, 2, 3, 4, right? So these are my 4 core. Let me kind of group these guys together a little bit. So here's our 4 core. I'm going to grab these 4 cores. I'm going to drop them right here. Just like that. We'll get rid of these guys down here. Okay, now here's my network card. And basically what we're doing is setting up a queue to go here, a queue to go here, and a queue to go to those last two. So we basically have established queues off of the adapter to different cores on our host. So as different packets come in, one packet's going to be handled by one core. We'll queue it up, right? We'll put another packet out here. We'll create some packets here. This packet comes in, gets queued up here. And if we got a lot of stuff coming in, we can spread it across these different queues. If it starts coming in really fast, we may actually back up a little bit. It would take a lot of traffic to do that. But if we're spreading the load of all these packets coming in across these 4 different queues to these 4 different cores, you can imagine how much better that would be than if I just had no queues and used just one core, right? So it makes the performance of receiving packets as they come into the host much more efficient because we're spreading the load of processing and bringing those packets in and distributing them to the VMs and the networks they're connected to much more efficient. So that's very important. So that's number 3. The other thing also that's important here is make sure that you install the proper VIBs. It may require a host reboot initially, right? So let's make sure we're working with the proper, VIBs that are available to get that driver installed correctly at the host level. If it's an OEM install from a vendor like HP or IBM, just double check it and make sure that you're good to go. Dot your I's and cross your T's. All right, moving right along. The number 4, most important thing we do before we deploy NSX, and this is a tough one, is called a Nic Teaming Policy. And I'll try to do this real quick over here. So this really depends on what type of switches you have top of rack. So let me just get rid of vCenter here. We didn't really talk about him anyway. We know we need vCenter, right? So imagine you have, say, 2 racks. And we have 2 switches on the top of this rack, and they're disjointed. We have 2 switches over here, and they're somehow stacked or aggregated together, right? So these 2 switches here basically appear as one to our downstream servers, and each one of these switches appear as separate switches. So if I have 2 adapters in each one of my hosts in each rack, right? These are my 2 network adapters. What's going to happen with NSX is I have to pick a Nic Teaming policy. So if these switches are completely separated, that means that one network card goes to this switch and one gets configured to this switch, right? Now here, even though they're two switches, and yes, we have physical connections to the two switches, that is true. In this case, because the switches are separate, I will need a separate VTEP to send traffic to each switch, right? Over here, I'm going to have one VTEP, and underneath it, it'll send traffic to the two different cards, right? So it's a little bit different. So if you think about the way the VMs will interact with this, right? Let's say we got 4 VMs here, and we got 4 VMs here. So what's going to happen is that when the traffic goes from this VM, it's going to go to this VTEP, to this switch, right? This VM is going to go to this VTEP, to this switch. This VM's traffic is going to go to this VTEP, to this switch, and this VM's traffic is going to go to this VTEP, to this switch. Here, this traffic from this VM goes to this single VTEP, and then the VTEP will dice the traffic to this guy. This VM will go to the same VTEP. He'll dice the traffic and send it here, right? And so on and so forth, because the VTEP is going to point to this guy as if it's just one switch, right? So as far as we're concerned at the host level, there's just one underlying VTEP with two physical cards, right? And then the VTEP is able to leverage both of those cards, right? Because it sees everything as one switch, right? So that's a very important concept there. So what are the Nic Teaming policies that we can use? The Nic Teaming policies are, for the one on the left here, the Nic Teaming policy we're going to use is called port ID or MAC hash, right? Either one of those will support having multiple VTEPs. So port ID would support the two VTEPs, MAC hash would support the two VTEPs. We recommend not to use MAC hash. That means every single frame we have to do a hash, generates a lot of CPU overhead. So this is the one that I would use in this scenario, and that would give me the two VTEPs. The other Nic Teaming policies I can use, I'll put them over here, would be static ether channel, enhanced LACP, and then there's one other one which would be explicit failover. All right, now what this means is that each one of these is going to give you a single VTEP. Now, explicit failover is different than the other two. Explicit failover means we're going to have one VTEP with one card active and one card standby. That's a little bit different. Now, the static ether channel and the enhanced LACP are basically, one is older, static ether channel is a little bit older technology, and enhanced LACP is newer. We recommend that you go with enhanced LACP. All your VXLAN traffic is UDP, and we have over 20 different hashing algorithms we can pick from with enhanced LACP, and we can pick the best one. And there are, I believe, 4 of them that are specifically designed to support UDP. And we can pick the proper one based on traffic flow, right? So for Nic Teaming, number 4, and the physical NIC, those two together are very, very important that we have a really good understanding of these and which ones we're going to use before we ever install NSX. The very last one is we have to, number 5, the last one for this video, number 5 is we have to set the MTU to a minimum setting of 1600 across the board, right? Now, what we're going to get is our VDSs will all be 1600 when we do our VXLAN prep. That we don't have to worry about. That's all going to be 1600. The VTEPs are all going to be 1600. That we don't have to worry about. So we're going to get 1600 across every single VTEP. What I do have to be concerned about is on the physical side, I need to make sure if Jumbo Frames is not already configured that I set all of these ports, or maybe the entire switch, probably easier to do the entire switch. Make sure every single port in the path of all my VXLAN traffic, every single port is going to be set to a minimum, and I emphasize minimum MTU of 1600. It means it can be higher, right? But it's got to be a minimum of 1600. And we don't necessarily have to go port to port. You know, most switch vendors will support us just configuring the entire switch to be 1600. And some of the newer switches, most of the newer switches, when I make this MTU size change, you'll not have to actually reboot the switch. So that's really important. All right. So we have to make sure that we can move that VXLAN traffic across the network. And to support that, the main consideration is the MTU has got to be set to a minimum of 1600. So there you have it. Those are my top 5 requirements, considerations, prerequisites for NSX, right? So before we ever even think about installing NSX, we go through all these first. Now, the one thing I do want to warn you about, there are very particulars for number 2, 3, and 4. Number 1 and 5 are pretty basic. So I'm going to create some additional videos here that dive into more detail on virtual distributed switches, on physical NIC selection, on Nic Teaming. So make sure you check out those videos. But overall, generically speaking, these are the things you got to watch out for, and this will be very helpful. Anybody could probably install NSX, but they may not install it correctly, and it may not be optimized. We want to make sure it is 100% optimized. We want to make sure everything's ready before we actually do the install. Okay, so there you go. There you have it. That's that video. That's a wrap. Thank you very much for joining me. I hope you found it educational. And if you guys have any more questions, make sure you go to www.27virtual.com and be sure to reach out to us if you have any questions regarding architecting NSX or deploying NSX in your environment. Thank you very much, and we'll see you in the next video.